Good morning, good afternoon, and good evening, depending on what time you're watching this video. My name is Sean Moritz, and I am a Senior Solutions Engineer for F5 Networks for the NGINX Business Unit based out of Sydney, Australia. Today, I'm going to be talking you through NGINX and how to use NGINX Plus to set quota limits for particular users based on request headers. In the demonstration, we'll be taking you through how to set quota limits, how to patch those quota limits once they've been reached, as well as what you can do with the actual request once that quota limit has been hit. So without any further ado, let's go take a look. We have a backend application and we have a user. So user A is going to want to access the backend application. Now you may actually want to monetize that content. So let's say only allow a certain number of requests for freemium users, or if it's in the case of testing and you only want students to be able to submit answers a certain number of times, you'd want to actually introduce some sort of blocking or redirection mechanism so that that user needs to take an action before they can proceed to access the backend application. We have a front-end proxy tier of NGINX Plus instances that are cluster aware and understand the state of the available requests across that cluster. This is just to demonstrate the actual statefulness of the front-end proxy tier that you have in place. We also have a load balancer in place that will load balance between those front-end proxies. So, to implement the user, what you do is you do a post request to one of those instances inside the front-end proxy. This will synchronize that state across each of those instances inside NGINX Plus. Now, when user A starts making a request, the consumer header with the user A value is sent to the front-end proxy and is decremented with each request that is made. Once that quota has been hit, it will reach a negative value. And once that negative value is actually requested, this is where you could redirect them to a payment gateway or trigger another action to be taken. Once that action has been taken, to reset that value for that user, you would just need to send a patch request for that user and add the additional requests available for that user. To understand how this deployment is going to work, I am going to need to just touch a little bit on how NGINX configuration files are set up. Now, I'll demonstrate on our front-end proxy because we have a nginx.conf, we have a conf.d directory, as well as a series of .conf files inside that directory. By default, when NGINX is loaded on an operating system, it will actually have this include conf.d star.conf directive and value. Now this is essentially where the configuration files are going to be hosted on this instance. NGINX is located in the etc/nginx directory. We have our nginx.conf file, and then we have a subdirectory there called conf.d. And I'll talk a little bit more about how the front-end proxy has been configured. For our load balancer, we have a pretty straightforward configuration here. We have a upstream listing called front-end proxy that's got a memory zone called front-end proxy. It's 64K memory allocated for that. We have a random algorithm for load balancing. This could be least time, least connections. It could be round robin, any of the algorithms available in NGINX Plus. Then we've got our servers that have been listed, and we have the quotas POC front-end proxy 1, 2, and 3, all on port 80. The keep alive directives are available there. We also have our server block, which is essentially telling the instance that it's going to be listening on port 80. The root location is just at /. We have a proxy pass to the front-end proxy listing over here. We've got our proxy HTTP version 1.1 and proxy set header connection. We do have an API dashboard available as well, so you can set up a dashboard so you can monitor what's actually happening inside your NGINX instance load balancer. and it just makes it handy to be able to see what's going on. You can also actually access the data from an API, and there is a Swagger UI available to be able to understand how that configuration works. So the load balance is pretty straightforward. The next thing we'll look at is the NGINX.conf for the front-end proxy. Now, this has the reason that we've actually changed the NGINX conf file is because we need to synchronize the state of the instances inside the cluster. Another thing to make note of in the NGINX.conf file is the load module, and this is the module for the JavaScript for NGINX Plus. And you basically load the module and refer to the module inside the modules directory under the NGINX main directory. The HTTP directive, we haven't actually changed anything here. The main log format is still the same. We've got the include conf.d directory, but we do have a stream server block, and essentially this is listening on port 9000. It's a zone sync area, so this means that it's going to synchronize the servers and the state when it is in production. Then we've got all those front-end proxies listed again. So quotas, POC front-end proxy 1, 2, and 3. We've got an error log available there with some information if needed and if there are any errors. If we have a look at the conf.d directory, a bit of different state here. Inside the front-end.conf file, we will see a directive called jsinclude, and what this will do is it will actually load the main.js file that is going to be evaluating and setting the decrement values when a request comes through. We will look at that in a moment. We have our log format called kv, which is essentially just going to be listening for these variables in the log file. Then we have our key value zone, and we've given it a name called quotas. We've allocated 1 meg of memory for that zone. We've got a zone synchronization as well, so that all of the instances inside the cluster will synchronize the state, and we've got a timeout of 32 days. Now the key value store itself is set by adding the directive key value. We are now going to be listening for the HTTP header called consumer. Something to make note of when you are dealing with headers in NGINX configuration files is if you have a header value that is uppercase and has dashes in it, then you will need to make all of the header values inside the configuration files into lowercase and use underscores where the dashes would normally be. The next is the quota remaining, and this is what we'll be setting when we actually do an API call to that NGINX instance to give a particular user a number of requests. A very important part about the key value store when dealing with NGINX Plus is you need to implement a state file, which is just a JSON file that you can refer to if you need to restart NGINX Plus. This means that because the key value store at the moment is just going to be sitting in memory, it means that when I restart NGINX Plus, all the values that I've set for the user quotas will be removed. The state file will make sure that these are retained if you do need to do an NGINX restart. We have an Upstream Backend App, and this is just the backend application which we're going to reverse proxy the request to once it has done the evaluation on the number of requests that have been made and the quota available to that user. We got our regular keep alive directives set in there, and then we have our server configuration. Now we're going to be listening on port 80. Again, we're going to be listening in the root directory, and we are going to be doing quite a few interesting things here with this request. The first directive that we're looking at is the Auth Request, and what this means is that NGINX is going to ask for authorization by sending this request to the check quota server block, which is located lower in this configuration file. We also have a mirror directive. Now, the mirror directive essentially takes the request that NGINX has received and that is going to be passing on to the upstream servers, and will just mirror that request to that location. So in this case, we are going to be decrementing the quota, which means that every time that someone makes a request to the server, the request is going to be mirrored to this particular configuration block called Decrement Quota, which is located lower in the configuration file as well. We're going to add the header X quota remaining, and then we're going to list the quota remaining. And then the next is the 403 error page, which is going to be called when there have been too many requests for the particular user. So once they've actually gone past the allowed number of requests, the authorization request is going to check the quota. If the quota value is lower than 0, then it will do a 403 response. And this is really where you will add the configuration for what you want to do when someone actually hits that quota limit. This may be to redirect them to a payment gateway. It could be to send a notification email. It could trigger a CI/CD pipeline. The options are relatively endless. The proxy pass to the backend application is set over here in the proxy pass directive. We've got some standard proxy pass directives that have been added as well. We've got a set header and the balance, and this is going to show what the quota remaining is inside the header when a response is returned to the user. Then we have a proxy set header front end and the server address. So this is essentially the front end server that is going to pass that request on. This is the local IP address of this particular instance. Now, we talked earlier about the location of the check quota. It is an internal request, which basically means that the NGINX is not going to go off this particular box to make this request. It's going to do an internal request to this same instance. Then we've got the JS content, and this is where NGINX is going to call a particular function inside that main.js file, which we will look at in a moment. So that's doing the check quota to see how many requests are left. The next location block is the decrement quota, and this is essentially where you will be removing the number of quotas remaining for each request that is made. So it is going to decrement the number of requests available to that user. Again, it's an internal pass. It's a proxy pass to the decrement service, which is the decrementservice.conf, which we'll look at in a moment. Again, some standard proxy headers that we would add to that instance. We have our location block, too many requests. We have again, added some headers. We're returning a 429 quotas exhausted. And then we have our access log with the key value parameters that we set earlier in the log format. So the decrement service, we have a upstream decrement service. We have a memory zone allocated for this. The server is the quotas front end proxy 1.1, and the port is 8999. The queue directive that we have listed here is essentially when a server is actually busy serving requests and the upstream server cannot be accessed immediately, NGINX will place the request into a queue. This is the value of the number of requests that can actually sit in that queue, and it can, by default, it will sit in there for 60 seconds. You can actually set a timeout parameter for that queue as well. We've got our keep alive directives added as well. We've got our server block listening here, which is listening on port 8999. And then in the location block, which is root, we have our JS content, and we're loading the decrement quota function from the main.js file. Again, another API dashboard so we can see what's happening inside the instances. Let's take a look at this main.js file. And what we have here is a function to actually check the quota. It is going to evaluate it against the request. If there is greater than or equal to 0 available in the quota remaining, then it will return a 204. Else it will return a 403 error. Then we have the function to actually decrement the quota. And this means that when the request comes through, it's looking for the actual variable inside the header. In our case today, we'll be looking at the consumer header, and the value would be the actual user as well. So if the value is, if a request is made, it is essentially going to remove a request from the key value store on the remaining quotas. In the backend application, we essentially have a backend app.conf, and this is just a server listening on port 80. It is listening on the root location of that directory. It is also going to apply a subfilter, and what a subfilter will do will actually look for content inside the response body, and it will replace with other content. So by default, NGINX when loaded will have this paragraph that if you are seeing this page, the server has been installed correctly. We're essentially going to be removing that and replacing it with the arrived from the front end proxy. Then we're also going to be replacing some of the other text, which is working, further configuration is required. And then we're going to replace that text with the quota remaining. So the HTTP balance available on that for those requests. The backend HTML file, it's pretty much just a HTML file, and it's got welcome to the backend. If you got X code at the server name, it arrived from the front end proxy, and the remaining quota for that user. If we have a look at the Docker Compose file, again, it's relatively straightforward. We've got our version, we've got our services that we're going to be deploying. The image that I'm using is my own personal image of NGINX Plus, and I am hosting this on my own container registry. It's private because I don't want the world to obviously get my own version of NGINX Plus, and it's to keep it safe from people being able to get the evaluation keys or the actual license keys, etc., etc. We've got our entry points, we've got the ports that we're listening on, the dependencies that we have. So we've got the back-end applications. I've given a network name. Then we've got our front-end proxies, which was front-end proxy 1. We've got front-end proxy 2 and 3 available there. And we are just basically adding volumes to this to actually refer to the NGINX configuration files that we have listed inside our configurations here. Then we got our backend application in at the backend, which again is the internal port is 5000, with 80 and 8080 being the external ports exposed. 8080 is there for the dashboards. Okay, so here we go. We have a Docker host. It's essentially just a CentOS 7 box with Docker and Docker Compose installed. I have all my configuration files set up inside this instance. Show you what that looks like. So I've got my Docker Compose YAML file. I've got my front-end proxy configurations, my load balancer configurations, old virtual machine solution. Don't worry about that too much. I've got my quota services and all the additional information that I need. So let's do the deployment of this application. All right. Backend app is done. Quotas, POC, front end proxy 1, 2, and 3 is up, and the load balancer is up. Do Docker PS, we can see all those instances are up and running. First thing we want to do is we actually want to set the quota for the individual user. There we go. We'll do curl ID user A. We're giving them 10 requests. I'm sending it to one of those front-end proxies. Because they are state aware with each other, the rest of them will update within a second. So we can see there 201 created. I can check and see what happens when we actually just send a standard curl request to the local host without any header credentials. Right, it comes back with a 401 unauthorized. That's because the NGINX Auth Request location block is sending that request looking for the header in the key value store. If it exists, great. If it has a quota, even better. With no quota, it will, and just the user ID, it will be an unauthorized as well. The next thing we can do is actually check how many requests are left in the quota for that particular user. So I'm just going to query the key value store, and it's going to return the actual user and the number of requests that are left for that user. Now if I actually make a request to that server with the actual header for for consumer being user A to that local host, we should actually start to see a decrement. So we've got remaining quota is 10. Again, we've got a 9, 7, 6, oops. 5, 4, 3, 2, 1, 0. Now it's going to return a quota exhausted error message. And this is the part of the configuration where you can actually decide on how you want to manage that request. You could actually forward that request onto a payment gateway. You can trigger a CI/CD pipeline by using an API request. There's a number of things that you can do. Send an email notification, create an alert of some sort, all options available to you. In this particular demonstration, we're just notifying you that the quota is exhausted. Now that quota has been exhausted, I now want to give that individual more requests. And there's a number of ways that you can automate this. The demonstration that I'm giving today is going to be using a cron job, and this is pretty manual. You can automate it via a CI/CD pipeline. Really, there's a number of ways that you can manage this. But I'm going to set that user's quota to 10 again. And then if I start to make a request, see that it's got 9 remaining, etc., etc. The other thing to be aware of is that if I do too many requests in one particular go, then you may actually start to see that some of the responses that are coming back are, I've got 4 remaining and I've still got 4 remaining on the previous request. The reason for this is the clusters of NGINX Plus instances in the front-end proxy only synchronize their state every second. So if you're doing hundreds of requests per second, then this will not update accordingly. Your users will get a few more requests than they have been allocated. And a way to alleviate this is actually set a rate limit on the load balancer in front of the front-end proxies. What I've actually got here is a script that I've written, which is just a bash script, and it's literally just going to do a curl command to the local instance every minute, according to the cron job. It's going to do this request, and it's going to set user A to have a quota of 10. So I'm just going to exit out of that and save. And if we have a look at the cron job, we will see that every minute it is going to run that particular script. So now when I do my requests, remaining quota is 0. So within a minute, it will actually come back with a 10. We'll just keep running this. You can see the time there, 47:53, 8, and now it should be back to 10. That's really it. Just going to shut down those machines. And that's it for the demonstration today. I do hope you found it informative. Quotas can be quite dynamic in nature and quite handy if you're looking to monetize some of your content or your APIs. If you are looking for more information, we do have our nginx.com webpage, which has a wealth of resources about the use cases of Nginx and how you can actually configure Nginx and NGINX Plus for different functions inside your application architecture. We also do have our alphabetical index of directives page, which will give you an idea of all the directives that are available inside NGINX Plus and NGINX Open Source. We also do have a alphabetical index of variables page, which will show you all the variables that are available in NGINX and NGINX Plus. And of course, there's a wealth of information on our GitHub page as well if you are interested in finding some examples of use cases of NGINX Plus. Again, my name is Sean Moritz. I do thank you for your time today, and I will see you on the next video.